Something strange is unfolding beneath Wyoming's peaks. A sudden, powerful force stirring deep underground, sending quiet ripples far beyond the state's wild.
And new tonight, an Idaho mountain climber is dead after falling from a jagged peak in Wyoming's Grand Teton National Park. Officials say Braden Dury from Kuna was with 2 other climbers when he fell 50 feet.
On a crisp October morning, as frost clung to the winding sage and elk trails, rangers stumbled upon a remarkable revelation at Grand Teton National Park. A fresh, sizable crack slashing through the stone, stretching nearly 100 feet across. A fissure that cleaved the ground in a manner rarely seen in the park's storied geological history. The night before, there had been no obvious warning or rumbling tremor. No sign audible to human ears that something dramatic was about to unfold. The fracture is new. It is widening, and it cannot be ignored. A stark reminder that no landscape, no matter how ancient, is ever truly still. Within hours, teams of geologists, park authorities, and emergency personnel converged on the scene, measuring and mapping the phenomenon with a mixture of curiosity and concern. The Teton Range has forever been a place of movement and dramatic geological change. Its peaks born of ancient upheaval, its valleys sculpted by a combination of fire, ice, and relentless time. Yet this event, a surface rupture so abrupt and definitive, left even seasoned scientists at a loss for words. As word spread and images of the fracture circulated globally, questions multiplied. What force could unleash such a rift in an area where the ground seemed securely anchored by deep time? Were the alpine freeze-thaw cycles driving an internal wedge? Or could the legacy of thawing permafrost, once a stable anchor to rocks and soils, be creating new vulnerabilities in the landscape? Most unsettling was the possibility of renewed activity along the Teton Fault, or hints of deeper magmatic forces, increasingly recognized as active beneath the regional crust. As scientists debated and warning signs were updated, one chilling notion persisted in the cold mountain air. If the ground can split open here, in a place defined by ancient silence and apparent stability, what other transformations might be unfolding, unseen, beneath our own feet? Chapter 1. The fracture appears. The story began in stillness. There was no dramatic earthquake, no avalanche roaring down the slopes, just the subtle, silent rearrangement of the landscape. Nearly missed, if not for an observant hiker near Hidden Falls. Upon arriving, park rangers found a chasm slicing through the trail, up to 3 yards wide at its broadest, extending roughly the length of a city bus, and vanishing beneath the surrounding pine forests. Water seeped from the broken earth, scattering across the frozen rocks in the first light of day. The scene was startling. Soils upended, roots torn as if by a force within, and boulders freshly disturbed. The crack at places was narrow, at others so wide that no bottom could be glimpsed even with powerful flashlights. Frost clung to stones, and the air hovered colder than ambient temperatures would predict. Likely a signal of moisture released from just thawed frozen layers. Park officials quickly cordoned off the site, warning of the possibility of collapse, and began immediate safety inspections. Field scientists, arriving with drones and specialized imaging radar, noted something remarkable. Weekly surveys indicated that the fissure was not static. Photographic and GPS data showed subtle but undeniable expansion. A sign that the underlying cause was not a singular event, but an ongoing process reworking the ground. Core samples revealed that the bed of the crack contained freshly disturbed soil and rock, some surprisingly cold and moist, almost certainly exposed by recent earth movement and not long-standing surface processes. The crack's sides were rough and jagged, the pattern uneven, with stones and organic debris cantilevered above the darkness. Faint vibrations were reported intermittently, and minor rockfalls echoed throughout the following days, testing the nerves of all nearby. Satellite and drone images gave context. Around Hidden Falls, the surface had shifted, showing a faint sag and a lateral offset that paralleled the local ridges. This alignment was not random. Historical fault maps indicated the fissure trailed the general axis of the Teton Fault, a reminder that even in apparent stillness, the Earth preserves traces of deep-running processes. No one could say whether this event was an isolated anomaly, the herald of a broad series of changes, or the result of quietly mounting pressure deep underground. What was clear, the land could rearrange itself overnight, and each new opening provides a fleeting glimpse into the living machinery below. Chapter 2: Unraveling the Cause. As geologists puzzled over the facts near the base of the mountains, several hypotheses quickly emerged. The Tetons, after all, are a meeting ground of fierce environmental contrasts. Burning summer sun, savage winter deep freezes, sudden thaws, droughts, and epic snowfalls all intersect in the high country. Chief among the possible causes was accelerated freeze-thaw cycling. Water trickling into the smallest cracks can freeze and expand, prying apart even ancient rock. In the last year, the region saw unusual alternations between bitter cold and unseasonable warmth. These extremes, captured by weather stations in the park, can produce immense pressure within the bedrock, a time-tested mechanism behind many landslides and splits in high-altitude terrain. Experts confirmed that robust freeze-thaw cycles often precede ground movement, especially where snowpack and soil layers are thinly spread across exposed stone. But surface temperatures and ice alone do not create sudden sizable ruptures. Deeper in the fractured earth, permafrost, soil long held together by persistent cold, has been melting faster than at any time in recent history. Soil cores from the fresh crack revealed layers of recently thawed ground, suggesting that changes in permafrost integrity may be undermining the stability of slopes, especially when coupled with droughts or intense rain. No one can precisely time permafrost degradation beneath each ridgeline, but the evidence is building that thawing ground is a factor. Yet the most unsettling data pointed to the possibility of renewed tectonic strain along the Teton Fault itself. New GPS and satellite measurements indicated that the crust beneath Grand Teton had been inching, almost imperceptibly, over recent months. This movement, while generally minor, had directionality. It aligned with the ancient fault, a known but rarely active tectonic feature. The Teton Fault runs for more than 40 miles along the eastern base of the range and is responsible for lifting the iconic peaks thousands of feet above the Jackson Hole Valley. Experts at the USGS noted that the fault has produced significant earthquakes in the prehistoric past, with geological trenches revealing major ruptures at intervals across thousands of years, each with the power to drastically reshape the surrounding landscape. While there was no evidence that a large earthquake was imminent, the possibility that creeping stresses might be focusing along this fault could not be excluded. While some observers referenced ancient local histories, there is no confirmed oral or archaeological record of recent large surface ruptures in the specific area of Hidden Falls. Instead, the convergence of three logical causes: enhanced freeze-thaw, thawing permafrost, and the reawakening of tectonic stress now frames the conversation about risk and response. What began as a solitary fissure near Hidden Falls had quickly become a larger question about the forces at work beneath North America's mountainous spine. Chapter 3: The Teton Fault, an Ancient Menace. To place this recent event in context, one must understand the Teton Fault itself. Running along the foot of the mountains for more than 40 miles, this fault is a boundary between rising peaks and subsiding valleys, a near vertical rupture in the crust. Over millennia, the Teton Fault shift has repeatedly lifted the soaring peaks and dropped the floor of Jackson Hole, producing the sheer grandeur and dramatic relief that define the park today. Each motion along the fault, even those only a few meters in magnitude, has the potential to drastically remake the landscape. While no major historic earthquake has struck directly along the Teton Fault since records began, geological excavations along the scarp have uncovered evidence of at least 4 powerful earthquakes over the last 10,000 years, with the last major slip believed to have occurred more than 5 millennia ago. These events lifted the range dramatically and shifted rivers and hillsides in a geological instant. Recent microseismic activity, weak local quakes, does pass through the region, but these have so far been too faint to relieve meaningful tectonic stress. Computer models by USGS scientists show that strain continues to accrue along the Teton Fault, although rates are low and the likelihood of an immediate quake remains modest by national standards. Still, the fact that the recent surface rupture near Hidden Falls appeared broadly aligned with the Teton Fault reawakened interest and concern. High-resolution data from drones and satellites enabled scientists to trace subtle topographic features, minor offsets and shifts in soil levels, mirrored on each side of the widening crack. Seismometers, newly installed in response to the event, have detected occasional microquakes and ground vibrations, but nothing to indicate a large tremor is imminent. In summary, while the Teton Fault is not thought to be on the verge of a catastrophic slip, the coincidence of surface fracturing, ongoing freeze-thaw, and slow tectonic motion is a timely reminder that the calmness of mountains can be deeply deceptive. The question now facing scientists is not whether the region will move again. History guarantees that it will, but how and on what timescale? By sudden earthquake, slow landslide, or yet another unpredictable process? Chapter 4. Threats multiplied. Landslide, earthquake, or both? As the crack widened, researchers worked rapidly to specify the main hazards: landslides, earthquakes, and the possibility of cascading events where one disaster triggers another. Grand Teton slopes are already prone to slope failures. Scars of old landslides, draped in forest or buried under glacial debris, are visible from ridgelines and rivers. The area around Hidden Falls exhibits classic ingredients for instability: sheer granitic outcrops, shallow soils underlain by frost, and water channels that can erode support from below. Once a new fracture develops, basic physics dictates that gravitational instability can increase. That is, more land may begin to shift, especially after rainfall or fast snowmelt. Satellite mapping and preliminary geotechnical analysis indicated the ground near the crack showed minor signs of downslope displacement. Water is a key variable. Sensors installed in response to the event tracked rising soil moisture in the weeks following the crack's discovery. In some instances, slow-moving earth, called creep, can precede larger landslides, and this is being carefully monitored on a daily basis. The risk of a major landslide, while still uncertain, is not theoretical. Notably, previous landslides in the greater Yellowstone Teton region have been documented in both historic and prehistoric times, some triggered by rapid snowmelt, others by distant earthquakes, or the initiation of new ground cracks like this one. It remains plausible that rainfall or freeze events could propel a portion of the slope down towards the valley, threatening both natural features and, in a worst-case scenario, visitors or infrastructure. Turning to earthquakes, the Teton Fault is geologically capable of producing events in the magnitude 6.5 to 7.5 range. A slip of this magnitude would reverberate throughout the park and beyond, potentially triggering landslides and altering the flow of local rivers. The most significant local analogue is the 1959 Hebgen Lake earthquake, just northwest of Yellowstone, which demonstrated how distant faults can jolt this region and induce landslides, ground ruptures, and new openings. It is noteworthy that while there are no anomalies in seismic networks suggesting a large rupture is imminent at the crack's location, the possibility of one event cascading into another is always present in mountainous, tectonically active regions. Unusual animal behavior, minor vibrations, and anecdotal rumblings are not uncommon near growing fractures, but these alone are not confirmed predictors of major earthquakes or landslides. Caution and vigilance, informed by up-to-date data, remain the operative principles for park officials and scientists alike. As this situation unfolds, residents and visitors alike are confronted with a difficult question. Could this crack really be the first sign of a more substantial rearrangement of the park's landscape? Chapter 5: The Eruption Question. Among all the hypotheses, few evoke as much public fear as the connection to nearby Yellowstone, a globally renowned supervolcano. The possibility of volcanic eruption catalyzed by tectonic activity is the subject of ongoing scientific debate and popular imagination. It is important to clarify that there is no scientific evidence of the Yellowstone supervolcano being on the verge of a catastrophic eruption. The region's magmatic system is closely monitored by the USGS and partners. Research shows that the area of greatest likely geothermal unrest is located in the northeastern part of Yellowstone National Park, somewhat closer to Grand Teton, but there have been no signs of impending violent activity in recent years. In 2025, the geologic data showed that only 2 major geyser eruptions were recorded, a marked decrease compared to the flurry of hydrothermal activity that began in 2018. In fact, recent analyses have concluded that the period of frequent activity has probably ended, and researchers have noted that Yellowstone is currently in a phase of relative calm. Globally, however, 2025 saw 63 confirmed volcanic eruptions, including 21 first-time events for the year, a signal that volcanoes are active elsewhere, though not, by current evidence, in the immediate vicinity of the Tetons. Geyser and hydrothermal activity remains closely watched, and any changes in ground temperature or gas emissions near the Teton crack are being recorded and analyzed for signs of deeper magmatic influence. While small amounts of volcanic gases such as carbon dioxide or sulfur may be detected at thermal sites, there is no clear data linking the specific Hidden Falls crack to increases in deep magmatic activity. Geological sensors continue to measure minor, ambiguous changes in soil temperature and pressure, but none so far suggest a volcanic awakening. Experts caution that while the tectonic fabric of the region connects the Tetons to Yellowstone, and that stress changes may theoretically interact, the best available science finds no imminent threat of eruption. It is accurate to say, however, that the fresh crack in the ground underscores the dynamism of this broader landscape. Tectonics, hydrothermal circulation, and climate all intersect here, and the unexpected always remains possible. Could this event inspire a re-evaluation of the links between tectonic and magmatic risk in the greater Yellowstone ecosystem? Absolutely. But there is so far no cause for panic regarding a major eruption. Chapter 6: The Ripple Effect. What happens next? The appearance of a sudden crack in Grand Teton National Park has consequences both practical and symbolic. Its ripple effects stretch across park management, scientific inquiry, and the daily life of people in and around Jackson Hole. Following the fracture's discovery, authorities intensified surveillance. Satellite imagery, high-precision GPS, and field inspections became routine. Hazard maps were immediately updated, and several trails and backcountry routes were closed temporarily to prevent accidental injury. Experts from multiple disciplines began sharing data daily, integrating radar, seismology, hydrology, and climate trends into comprehensive risk models. Urgent, organizational. The growing fracture and related risks catalyzed local emergency planners to refresh disaster protocols. Earthquake safety training gained renewed importance, not just in schools, but also for seasonal workers and tourists. Drills and communication strategies were modernized, and brochures detail the best responses to landslides, tremors, and other natural hazards. Meanwhile, scientists recognized that their understanding of landscape stability must be flexible. The extension of the crack, observed week to week, prompted re-examination of other at-risk areas. Could similar features develop elsewhere in the park, or be hidden beneath forest canopies awaiting discovery? Teams now survey for subsidiary cracks, small landslides, and minute shifts in ground level. On a broader scale, the uptick in global volcanic eruptions in 2025 is set alongside the Teton crack, as a reminder that, planet-wide, Earth's interior remains full of surprises. In the American West, every fresh break in stone is seen not simply as a local event, but as part of a living, changing system with links to the global geodynamic engine. Now, as Grand Teton faces an uncertain short-term future, residents and planners are left with deepened respect for the hidden energies below, and a sense that even iconic landscapes can and do change rapidly. Their practical challenge: plan for the observed, prepare for the plausible, yet avoid panic about theoretical, unsupported dangers. Chapter 7. Are we too late to listen? Change in the mountains has always been measured in epochs, until it leaps suddenly and unmistakably into human lifetimes. The new crack near Hidden Falls stands as an unequivocal warning. The immense forces shaping Earth are never entirely spent. Tectonics, climate, freeze-thaw, and chance all play their unpredictable parts. Some tremors are too weak to be felt, some cracks too small to see, until suddenly, the silent work beneath the mountains breaks through. In 2025, as eruptions dotted the globe and seismic networks tracked mounting subtlety, Grand Teton National Park added its own chapter, its voice unmistakably part of Earth's ongoing story. What does it mean for the world when mountain, stone, ice, and valley surrender to abrupt reordering? Is this just another passage in the chronicles of the Rockies, or a unique warning, asking us to pay attention and re-examine the permanence we take for granted? Tonight, as the moon rises over the Tetons and a new fracture carves its way into the map, one ancient truth stands clear. Earth speaks continuously, sometimes in rumbles, sometimes in whispers, sometimes in the sudden opening of stone. For those who watch and listen, the warning is unmistakable. What once seemed unchanging may open again at any moment. And the next page in this story, it's unwritten, waiting, like the land itself, to break free.